Hi folks, Dr. Rob Barrington here with some more nutrition advice. This video is going to be on anxiety, and it's going to be part one of a series of videos on anxiety that are going to give some nutritional strategies in order to be able to treat and reverse anxiety. In order to be able to do that, the first video is going to be quite technical, and I wanted to do a video that explains exactly what anxiety is, or our current understanding of what anxiety is, and I wanted to put together some information so that you can understand the background of basically the damage that is occurring, the physiological changes that occur when anxiety develops in the brain, and on what changes and what implications that has for your health. So this one is not going to contain that much about nutritional strategies. That's going to start in part two. So if you want to miss this and you don't really care what anxiety is, what the underlying physiological reasons for anxiety are, you can skip straight to part two. Okay, so those people that are still here, I'm going to talk about the changes that occur in order to cause the development of anxiety in the brain. Now, the first thing to say is that anxiety and depression develop in very similar ways in the brain. So, for example, the underlying mechanisms that cause the development of anxiety are almost identical to the underlying mechanisms that cause the development of anxiety, but they tend to manifest different in different people. So while somebody might develop depression for a particular reason, someone else might develop anxiety. But this series of videos is going to be primarily on anxiety. So first of all, what is anxiety? Well, anxiety is an emotion that is related to fear, and that fear is seated in the primitive part of the brain. Fear comes from the limbic part of the brain. That's the primitive part of the brain, and it's the part of the brain that controls really our primitive emotions, so our underlying drives. So fear is one of those drives. It's different and distinct to the upper part of the brain, which has more human characteristics, which is thought of more as the conscious thinking memory part of the brain, which is the cerebral hemisphere, and that's the upper part of the brain, which is very highly developed in humans, and generally is bigger. It's larger in more intelligent animals. But the limbic brain is at the base of the brain. It's part of the brain stem, and it's the primitive part of the brain that seats our emotions, and fear is one of those emotions. So it's no surprise that's where anxiety develops. Now, anxiety is really it's a condition that is the development of an irrational fear. So fear is perfectly normal. Everybody's afraid of something. Most people are afraid of something. But what separates anxiety from fear is that anxiety is seen as an irrational fear. So a fear that you shouldn't really have, because the thing that you're afraid of is really not going to hurt you. But that's what anxiety is. It's worrying about things. And people say, don't worry, it's not a big deal. But if you've got anxiety and you are worried about it, you often worry about things that don't require you to worry about them. And that's the problem. It's an uncomfortable feeling that you get all the time for no reason. That's the problem. Usually when you get a fear, you can say, this is what's causing my fear. You remove that, and therefore your fear disappears. So if you're afraid of spiders, you take the spider, you put it outside, your fear disappears. If you have anxiety, that's different, because the anxiety isn't linked directly to anything rational. It's an irrational fear. It's a fear of things that you either can't understand, or it's a fear of things that you can't remove because they're so irrational that you shouldn't really be afraid of them. And that's the problem with with anxiety. It causes this kind of delinking between the thing that's causing the fear and the actual fear. So it is a dysfunction that's not normal. So I mean, that's basically what it is everybody's had anxiety. Everybody feels anxious at some point. The difference again is that anxiety is kind of a normal thing. Everybody gets a little bit afraid about things at certain points, but it's when the anxiety becomes chronic and it becomes part of your life, and it starts to become very irrational, and you're afraid of things for no reason. You become anxious for no reason, And that's really the problem. That's when it becomes pathological. That's pathological anxiety. And there are different types of anxiety. So, for example, most people have general anxiety syndrome. If you suffer from anxiety, that's what most people get. It's just a general uncomfortable feeling. Everybody knows what that feels like. Your heart rate goes up. You feel a little bit. You can't think straight. You become a little bit kind of lightheaded. It's not a very nice feeling. But there are other types of anxiety. So, for example, Obsessive-Compulsive Disorder. You're the type of person that has to turn all the lights off, check the lights are off before you go to bed. You have to check the door 4 or 5 times before you believe that it's, that's obsessive compulsive disorder, and that is a form of anxiety as well. So if you have obsessive compulsive disorder and you do those kinds of things, you are suffering from a pathological condition and you do have anxiety. Another very serious form of anxiety is post-traumatic stress disorder. Very, very common to suffer after you've had a major accident or some kind of major trauma. Very common in veterans that come back from war zones, battlefield stresses. They're quite, they're very well known to cause post-traumatic stress disorder, and that's another form of anxiety. They're all linked together. They manifest themselves in different ways, but the underlying pathologies are all the same in the brain. They're very similar pathologies. The changes that occur in the limbic system of the brain are all very similar. And they just manifest in different ways depending on the type of stress that you've been exposed to. So this series of videos is going to be for all of those people that have general anxiety syndrome, people that have post-traumatic stress disorder, and it doesn't have to be vets. Many people in everyday life get post-traumatic stress disorder. Maybe a loved one dies, maybe involved in a car accident. There's all sorts of reasons why you can get post-traumatic stress disorder in your everyday life. Or maybe you've got obsessive-compulsive disorder, which is much more common than people think. Everybody has a certain element, I think, of obsessive-compulsive disorder in their lives. And it's another way of the body expressing the fact that underlying there is a pathology in your brain that has been caused by by stress. So what causes these feelings that we get, these anxious feelings that we get? What's the underlying mechanism in the brain that changes? What happens? So really all of this stems from stress. At some point you will be exposed to either a traumatic acute stress, so that could be what leads to post-traumatic stress disorder, or you might be exposed to a more chronic stress. But really the overall effect is the same, and that's a massive release of stress hormones. And in a way, chronic stress is very similar to acute stress. And we say there's an acute event that causes stress, but that acute event can cause the continual release of cortisol. So when we're exposed to stress, we release our stress hormones, adrenaline, noradrenaline, cortisol. And it's cortisol really that we're focusing on, because that is what initiates the changes in the brain. But if we're exposed to an acute stress, so for example an accident, or a short period of very high stress that might occur in a battlefield scenario, something that's very upsetting, that can actually be a chronic form of stress, because you relive the moment, and it's that reliving of the moment. Every time you relive that moment, you release more cortisol. So you go back to the original point of injury, and you release more cortisol by thinking about it. So although acute events can be thought of as situations where there is a single release of a very large amount of cortisol, in reality that is a chronic event as well, because that event is so stressful that we relive it, and every time we relive it we release more cortisol. And so really what we can say is the initiation of anxiety is caused by a chronic release of cortisol, and that cortisol really is designed to help us. Cortisol, it's a stress hormone. People think, well, that's a bad thing, isn't it? It's really, cortisol is a very good thing. It's designed to get us through the initial stress. The trouble is that when the stress becomes chronic, that cortisol becomes excessive, and then it starts to have detrimental effects in all over your body. But obviously we're interested in what it does in the brain. So we release lots of cortisol. We've had a traumatic event, or we're under stress, a chronic stress with very small amounts of cortisol being released over time. But the point is, we're not recovering from that event. That event has not been removed. We're either reliving it or we're continually exposed to it. Obviously, the best way to get rid of anxiety and stop it developing is to remove the stress to start with, to get rid of the cortisol release. But if you can't and you don't, then you will get a mood disorder, or ultimately you'll get some kind of mood disorder, and anxiety can be one of those. So the cortisol is released. What does it do in the brain? So the cortisol goes into the brain. It's released within the brain. It's released in all tissues. It passes around in the circulation, and what the cortisol does is it initiates inflammatory cascades. So it releases chemicals such as cytokines. It releases chemicals such as nuclear factor kappa beta. It releases things like tumor necrosis factor alpha. It releases things like interleukins. It releases all types of immune modulators, small chemicals that react with cells, that change the function of the cells to a pro-inflammatory state. And that's one of the things that cortisol does. Now, again, that's a normal reaction to a stressful event. That's a normal physiological thing. But remember, we're talking about chronic stress, chronic levels of raised levels of cortisol, and that means chronic inflammation. And when inflammation becomes chronic, it becomes damaging. And the reason chronic inflammation is damaging is because inflammation, as a side effect, all of these immune modulating chemicals that I've just named, they all cause the release of free radicals. They cause cellular changes which cause the generation of free radicals. And as those free radicals generate and there becomes more of them, the antioxidant mechanisms within cells fail. In other words, there aren't enough antioxidants to mop up all of the free radicals. And at that point, we say that the cell is under oxidative stress. It's under a state of oxidative stress. Too many free radicals, not enough antioxidants. That state of oxidative stress causes many different changes within the cell. And one of the changes that happens is that in the limbic system, in the brain, levels of a protein called CREB decrease. Now that is cyclic AMP, CREB, cyclic AMP element binding protein. So that's CREB. Now CREB is a control protein that controls other proteins, and one of the other proteins that it controls is called brain-derived neurotrophic factor. So cortisol, inflammation, generation of free radicals, the overwhelming of the antioxidant defenses generates oxidative stress. That reduces levels of CREB, and in turn that reduces levels of brain-derived neurotrophic factor. And that's the key part of this cascade. Brain-derived neurotrophic factor is required by the limbic system, or by the brain, in order to be able to keep its plasticity. The cells have a plasticity. They pass neurotransmitters between the cells along long pieces of string. They're neurons. They're not like round cells. The neurons in the brain are like long pieces of string. They have connections, multiple connections, and they require plasticity to be able to pass the messages from one to the other. They pass neurotransmitters. Some of them will inhibit other neurotransmitters. Some of them will excite them. They'll use GABA. They'll use serotonin, noradrenaline, adrenaline, dopamine. All of these neurotransmitters, they interact in the neurons in order to be able to maintain the function of the brain. And those neurons require a plasticity. They require an ability to be able to pass those messages efficiently. Brain-derived neurotrophic factor is the chemical that allows that plasticity to be inherent. It's there in the brain. If you remove or reduce the levels of brain-derived neurotrophic factor, you reduce that plasticity, which reduces the communication between the neurons, and it's that which causes anxiety. In the limbic system, when that system breaks down, brain-derived neurotrophic factor levels drop, that plasticity breaks down. That is what is thought to be the cause of anxiety. Now that is also it's thought to be one of the causes of depression, and I will cover depression in a different set of videos, but effectively this is how mood disorders develop. And the reason I wanted to do this is because looking at this cascade, there are multiple different places that nutrients and nutrition can affect that cascade of events that come from cortisol all the way down to membrane plasticity. You can affect them all with different nutrients. You can reduce levels of cortisol. You can reduce levels of inflammation. You can reduce levels of oxidative stress, increase antioxidants in the cells. You can increase levels of CREB. You can increase levels of brain-derived neurotrophic factor. And you can also increase membrane plasticity, all with different nutrients. And so I wanted to put together a series of videos that shows how each one of those steps can be beneficial, how each one of those steps can be beneficially improved if you have anxiety, in order to be able to put together a nutritional strategy to be able to treat anxiety. Now, treating any one of those steps will obviously break the pathway. There is a pathway going down. If you can break that pathway, eventually brain-derived neurotrophic factor levels will increase again. But being able to affect all of them is obviously going to be more effective. It's going to allow the nutrients to have a synergistic effect, and that's really how nutrition works. Nutrients work synergistically. So this is one particular area where synergism between nutrients is very likely to cause larger improvements in the anxiety. And I think this is one of the key things that people miss when they're trying to treat anxiety. They go on the internet, they look at a video. You're trying to find a video, I've got anxiety, I want to treat it. I'll look up a nutrient, and you see a video, and I've done these videos. You say this nutrient affects anxiety and improves it. But what I wanted to do is put together a series of videos that shows how each one of those steps is affected in a different way by a different nutrient. You put all of those nutrients together and you're affecting that whole pathway. That has got to be a more effective way of treating anxiety. So that's what this series of videos is going to do. I'm not sure how many parts this is going to have, but we'll see. It's going to have at least one nutrient for each one of those parts in that pathway. I'm going to explain how it works and what it does. And hopefully that will give people who have anxiety, which is it's very, I think a lot more people have anxiety than is acknowledged. I think it's fairly common in this very stressful world that we live in. And hopefully this advice will help those people. So I hope you found that interesting. As always, eat well, stay healthy, and protect yourself. And I will see you soon for another video. Take care.